Okay, so today we're doing matching and allocation problems, and what we're looking at, they're called bipartite graphs. So it's when you have two groups and the groups are given each person or each thing in the group is a vertex, and then how they connect is, ends up being the edges. So it does look like a network, but it's also, it sort of looks like a bit of a different graph. So if you have a look here in this example, we've got like 4 people, and so you've got 4 people and then you've got 4 instruments. So you can see from this, I can see that Anastasios plays the clarinet and the trumpet. And so it's a way of showing what, a certain person can, or what one thing can do and lead to. So you will see that if you have the 2 groups will have the same number. So you can see there's 4 people here and then there's 4 instruments. So that will be how it'll always look like that. The groups will be the same amount, okay? And then obviously you can see the vertex. So what we use these for is like for an example. So we have a small independent improv theatre group that need to assign cast members to jobs. Each cast member should be assigned 1 job. So you can see the first one there they did for you. So Aisha can do hosting, flyers and websites. So in the end you had 5 people and there's 5 jobs. And what we've done is we're just connecting what they can do. So if you look, you can see Colin can do hosting, training and ushering, and I've done that in the orange. So you can see I'm connecting him with those 3 jobs that he can do. So when I produce that, this is a bipartite graph. So I've got, in the end, because I've got 10 vertices there, okay? Okay, so what we call that, we have this thing is allocation. So an allocation is made when each of the vertices in one group from the bipartite graph are matched with one of the other vertices. So we saw that the people were matched with an instrument, or that one before, the theatre jobs were matched with the people. So an allocation is possible when both groups have exactly the same number of vertices. So remember I said there's the same amount of people, the same amount of jobs or things will be matched up to. Okay, so here's an example of another example. So we've got Nick, Maria, David and Sabitha, and they all present on TV, travel show, and each presenter will be assigned a story to film about one country they have visited before. So they want you to construct a bipartite graph. So what you're going to do is you're going to have the names down like one side. So we have Nick, Maria, David and Sabitha. And then we're going to have because there's 4 people, there's going to be 4 countries there. And I can see Greece is one, Malaysia, Brazil, and France. Okay, so in a bipartite graph, they're going to, obviously that's all each a vertex. And then the edges are going to be the connection. So Nick can go to Greece and he can go to Malaysia. He's been to Malaysia, so he could do the presenting on that. Maria, she has been to Greece and she's been to France. Sabitha, has been to Malaysia and Brazil. And David has been to just Malaysia. So what you want to do when you're allocating, if you think about it, you want to see if you've got one line going into somewhere, that's the only option you've got available. So for example there, David only could go to Malaysia. So he's going to present, we're going to say David will present on Malaysia. And I'll just leave it. That means Malaysia. I've abbreviated it. Then if you looked at over there in the countries, there's only one connected to Brazil, and that's Sabitha. So Sabitha will do the presenting on Brazil.
Nick is there. No, that's not Brazil as well.
Did he? Did I not do that one?
Yeah.
Oh, sorry. So Nick went to Brazil. But, okay. All right. So take that back. But Malaysia's already gone, and Sabitha could only do Malaysia or Brazil. So we'll give her Brazil. Okay. Can you see that one? Yeah. Yep. So then we keep going. So if you cross out your options, so we've got Brazil and covered. So we've only got Greece and France to do. Now, there's only one line going into France, so who does that? It's Maria, I think. So Maria will have to do the France, and then we've only got one left now, which would be Nick, which can do Greece. It says over here to highlight allocation, definite allocations. So that was like David, he was a definite. There was only one way to go. And was it France? Only Maria. Was it? Oh no, we said someone else could do that. Was it? No, only Maria could do France. So that was a definite as well. And then you could work the other ones out. Okay, so now what happens is, so that was sort of allocating jobs. But then what happens is we give people do certain jobs with certain time limits. So then what are we going to do is we're going to get given all these people. So you can still see we've got 5 people and we've got 5 jobs here. So we've got building stage, fixing curtains, and we've got the time they would take to do all those jobs. So what we want to do is often you want to allocate everyone the job, but you want to get this done in the minimum, the lowest time. And they say down here, they say in the least amount of time, because obviously this is a business, you're going to pay people per hour. So let's get the shortest way with doing this. So we're going to show you a couple of methods, and you must know the inspection method is quite easier, and the inspection method is like common sense, or you can sort of logically work it out. It's not hard, like try to pick who does the smallest and all that. But the next method, you do have to know. The VCAR are asking you know that method, so you will get tested on the method, which we'll do in a minute. So first of all, let's just do the allocation method. The method by inspection. So what you do is you've got these are obviously the jobs along here, and if you think about it, you want the person to do the quickest job, the quickest person on that job. So what you do is first just circle all the lowest times, because they will be the quickest, yeah? So for job S, it was 11. For job C, it was 7. For job W, it was 4. For job F, 8. So there was 3 people who could do it the quickest, and P, there was 3. Oh yeah, sorry, 2 on 4. Awesome. So what we do there, so we've done that, and then you have a quick look, as like before, have a look at, if you have a think about it, who could, if you go along the jobs, there's only one here, isn't there? One person who, there wasn't 2 people that are quicker. So we might as well put Ryan on the curtain job. So I'm going to say Ryan, he's going to take job C. And I'm going to put the time he took, which is 7, because we want to know overall what's the least amount of time. And we're assuming they all have to do the jobs one after the other, okay? That's what we're going to say. All right, so then we cross off. If you cross off Ryan, because we've already allocated him a job, so we'll cross him off. So then you have a look down. Can you see I've only got one person now on W, yeah, because Ryan's now got a job. So I might as well give the W job to who? Who am I giving it to? Colin. So I may as well give Colin the W job, and I'll record that he takes 4 hours to do that. So then I can get rid of Colin. He's not in the picture. Now I can see there's another one now on job S. There's only one person there, and who's that? Josie. So Josie can do job S, and she took 11 minutes. So I take Josie out of the mix, and then I'm left with job F and job P, but only Wayne can only do job F. He can't do job P, so I may as well give him F, and that's 8. And then Aisha can do job P, and she spent 3. So then you go, all right, and then you total them up to get the least amount of time. So we total them up and we end up with 33 hours is the least. Okay, so the next method we're going to do is the Hungarian method up here. I'm going to skip over these pages. What you do then you go to this. So if it's not enough, and then we do these other steps. So I'm not going to show you on this one. I'm going to show you, we're going to go through this process again. And you would go to that, we're going back, sheet I gave you. Okay, so this is the other method of allocation, and it's called the Hungarian algorithm. And so remember, an algorithm is just how you steps on how you do something. So you just follow the same step every time. Okay, so what we've got here is Amy, Beth, Kate and Dana offer quotes on how much each of them will charge to complete 4 different jobs. And the jobs are P, Q, R and S. The table summarises these charges. So this is in the charges. Use the Hungarian algorithm to minimise the total cost. So say I had all these contractors here and I've got all those different jobs. I might want to get the lowest price here. So I might pick different people for the different jobs I've got going. So the first step in the algorithm. So what we're doing, we're still trying to do what we did before. That's the inspection method. So this is just another method. So what we do, the first thing we do in the algorithm is you look at the original table, and we're going to deduct the lowest number of each row. So I've highlighted it there in purple. For the first row, 17 was the lowest. The second row, 18 and 14. So what you can see, then we move to here, and you can see obviously 17 minus 17 is 0, and that's why we're getting these numbers across here. 24 minus 7 is 7, and that's how those numbers come about. Okay, so that's the first thing you do. Once you've done a row, what they call that is a row reduction, okay? So you've done the row reduction. You took the smallest number from everyone. So then the next step, you're constantly doing this next step after every little bit. So after this step, what we do is we attempt to cover all the zeros with a straight line, and you want to use the minimum amount of straight lines to try and cover your zeros. So what you can see there, like I can either go vertically down like they did there, right? So that would cover my 2 zeros. If I did the other way, I still would be using 2 lines, wouldn't I? That's the lowest amount of lines. So what happens is once you do that test, you put the lowest amount of lines to get rid of all the zeros. Your lines need to be the same number as tasks. So there are 4 tasks, we need 4 lines, but at the moment we only have 2. So that means we move to the next step of the algorithm, which is to do a column reduction. So the column reduction means we take the lowest number of the column, and that's what we're at now. So the lowest number of that column is 0. The lowest number of that column is 0. So this one is 1 and this one's 2. So when you'll go on to this next, so this is the column reduction. It has happened, yeah? So you can see the numbers have had those lowest numbers deducted from it. So then once again, we put the crosses over the numbers. So we can see if we go through them, we only need to use 3. That's the minimum amount of lines. So 3's not 4. We need 4. So we're still not there. Okay? So what we now do, so sometimes it will happen earlier. So we'll see that in a minute, but it's still not happened. So we're going to have to do the next step of the algorithm. So with the column reduction hasn't worked, so we go to the next step. So what the next step is, you take this, you take the smallest uncovered number. So what we mean, so we've done those crosses, those green lines. So all the numbers that aren't covered, 1 is the smallest, and I've highlighted that. That's the smallest uncovered number. And what we do is we take it away from all the uncovered numbers. So you can see I've wrote that's what we do. But we add it to the ones that have 2 lines going through it. So see those 2, they had 2 lines going through it. If you've got some of them, you add the smallest number. So if you go over here, you can see they're the ones that had it added, and those other ones highlighted in purple, they were the ones that had the smallest number retracted. Okay? So now we've done that, just to show you, I'll do it up on this one to show you how they got to here. So we then again do our crosses, so our lines. So if you look, if I go, so if I cross over 1, 2, 3, 4, even if I did another combination, I still, like say I did it that way, you know, it's still going to be 4 lines. There's 4 lines and there's 4 jobs, so I'm now okay. Okay. So I'm now okay. I've got the same amount of lines as there is jobs. So because I have 4 jobs, see 1, 2, 3, 4. That's good. So then what you do with all this table now, with all these numbers that have been changed, you circle round the zeros. So you can see in the blue there, I'm circling, there's a 0 in Amy, 2 0 in the Beth row, 1 in Kate, and 3 in Dana. So what that does, a 0 indicates that the person can do, is a person that could do that task. And then once you've done that, you've got that, they then ask you, you set up the bipartite graph, and you can do the same. So you could just go, all right, now that means Amy can do job P, so you can see she's done job P, and so on. So then you allocate your jobs. So I'm going to get Amy's the only one for P. So, Amy's, that's the only job she can do, so we'll give her that one. And same with Kate, can only do Q. So I go back to the original times, and I'm getting those times. So Amy took 17 minutes to do P. We got Kate to do, Q. And then R's only Beth can do. So Beth did R, and then I only had S left. So we get Dana to do that one. And then we add them all up, and the minimum cost was $64. So on the left, I'm going to do inspection in the purple. So what I've gone through each task, and I've collected the smallest time to do that task. Okay, and then I go through. So then if I look across, Anna could only do task C, so I gave her that. If you look down there, Dharma her only one is task B, that's her lowest, so I might give her B, and that's 2. And then, so if you want, you can cross off the person or the task. So if you think about it, I've already done task B and I've already done task C. So if I look now, all right, it means Christian needs to do task A. He'll do task A at 4, and Jessica will do task D with 3. And then we'll add all that up, and we'll get 11 hours. I'll say this was hours, I don't know what it is, hours, minutes, whatever. 11 we might just, I should probably, because they don't say what that is, I'm going to write units, okay? Just so you don't keep writing hours, it might not be hours. So units, 11 units is the smallest. All right, so that was just by inspection. Much easier, much quicker, but the Hungarian algorithm is something they want you to know. And what they'll do is they'll give you questions halfway through the process and say continue on. So you need to know what's going on. So what I'm going to do here, I found it easier if you just do, like I just do it on the left. So first of all, I'm going to go through it. I'm going to do a row reduction. So what I do is I'm going to do it in blue and I'll put the numbers that it is on the left just because it just makes it easier. I don't have to keep writing everything out or forgetting about it. So I'm going to do the lowest number, which was in each row. So in that top row, 2 is the lowest number. So if I take 2 away, that'd be 4, 1, 0, and 3. So the lowest number in the second row is 2. So 2, 0, 1, and 5. The lowest number in the third row is 3. So we'll get 0, 0, 0. And then the lowest number in the last row is 2. So we get 6, 0, 7, and 5. Okay, so now if I try and do my, I'm first going to try and do my cancel all the zeros with lines. So if I do, I could go 1, 2, 3. So how many tasks are there? There's 4. There's not enough, what do you say? There's not enough lines to match. So we're going to have to go to the next step. So the next step is I'm going to do a column reduction. So I'm looking at the blue numbers and in that column it's the smallest is 2, this one's 0, this one's 0, and this one's 3. So on the right, I'm going to put all the, what those numbers are. So 4 minus 2 is 2, 2 minus 2 is 0, 3 minus 2 is 1, and 6 minus 2 is 4. And then this one in the column, this one won't change because if you minus 0 from anything, same with the next one. And then the final one is 0, 2, oh, yeah, sorry. Yeah, good point. So this one actually, the lowest number was 0. So let me rub that out. Yeah. I think that's what, is that what someone was saying out there? I think. All right, so that one was 0, so that one will stay the same. 3, 5, 0, and 5. Okay, so now got to try and do the cross method, the lines, but through the red one, through the green one. So if I go 1, 2, 3, 4, is there a quicker way? Can I do it any quicker? What about if I did it with some horizontal? So maybe I'll go 1, 2, I'm looking at the green, 3, but I still need to get this one, so 4. Can you see I can't, the minimal way to do it is with 4 lines. Sorry? Okay, so that was a good question. Someone said, so there was a few options you could cross it out, but the minimum amount of lines you'll need is 4, which matches the amount of jobs. So I'm ready now to allocate jobs. So I'm going to allocate with the purple in the green one. So any green 0, I'm going to circle. Okay, so then I know what job, and now I can do my bipartite graph, whatever, Jessica and Dharma, and then we've got task A, B, C, and D. So Anna, she can only do task C because she's got the 0. Christian can do...
If you're taking 3...
Okay, so now Christian, he can do task A and B, so I'll go out to A and he can go to B. And Jessica can do B, C, and D. So Jessica, B, C, and D. And Dharma can do B. Okay, so then you allocate your jobs. So I can see Dharma can only do B. Now you have to go back to the original, and that's why it's handy to have this, because now I can see Dharma is doing B, but there's the original, so it's 2. Okay, and if I go to, I think Anna could only do 1. Anna could only do C. So Anna is C, and she equals, that's 2 as well. And then who else are we going to allocate? We're going to allocate, so we've done job B, so all of that's out, and we've done job C. So we've got D, which looks like only Jessica. Jessica will do D, which took her 3. And then we've got left with, who have we got left? Christian. And he's going to do task A for 4. Okay, and then if you add all them up, we're going to get 11 again. Oops. 11 units. So you can see how we got the same answer. All right, so we got up to here and Amari did the last 2 jobs. So we looked at Jocelyn underneath, and Jocelyn does job 3 quicker. So we're going to give Jocelyn job 3, which took him 6, and we'll give Amari job 1 that took 4. And then we'll total that up and we get 18. Okay, so I'm going to try this 5B, and we're going to use the Hungarian. So first of all, we're going to do a row reduction. So I'm doing the same colours I did before. I'm going to do the row reduction, and I'll write them on the left in the blue. So the lowest number in that top row is 4. So that will be 0. That'd be 3, 4, and 2. The next lowest number in the second row is 4. So that one's 4, 0, 2, and 5. We then have 3, 0, 6, and 4. And then we have 4. So 5, 0, 3, and 1. So I'll go and test with my lines. I'm going to draw the lines in red. So I've got, if I go like this, 1, 2 would be the minimum amount of lines, so I'm nowhere near 4 jobs. So I'll go on to the next step, which is a column reduction. Okay, just so people got a little bit confused there, in the blue we've taken the lowest row number. So this one was 4, this one was 4, this one was 3, and this one was 4. Just so you know, that's what we did. We did the line test, and then we saw it only took 2 lines to cover them all. So now we're going to go and do the column reduction. So the column means I take the smallest number. So in the blue column, that's 0, 0, 0, and 1. So the column, these first 3 columns, because I'm minusing 0, they're actually not going to change. And so we're copying, I'm minusing 0 from the blue numbers, or whatever number I've got to minus. Now I've stuffed that one up. I'm going to minus the numbers. So I'm minusing 0. So this one will be 2, 6, and 3. And then the last one, I'm going to minus 1. So that's 1, 4, 3, and 0. Okay, so now I'm up to trying to cross out my all my zeros. So in the lowest amount possible. So I'm going to go down this way. That would be 3. That gets rid of 3. If I go across, I'm looking at the green numbers. That gets rid of that one. And then there's 1 down here. But when I do that, so what I see is I only did 3 lines and I have 4 jobs. So that means I'm moving to do the next step where you find the smallest number that's not covered. So I'm looking at the green numbers and the smallest number that's not covered by a red line, and I believe it's 2. Would you agree?
Yeah.
So 2. So what we're going to do is we are going to deduct 2 from all the uncovered. So that would be those ones, this one, and this one. Okay, and then we are going to add it to the one that has, if it has 2 red lines going through it. So I'm going to add 2 to those 2 there. So this one I'm actually going to write the new numbers underneath because I've now got too many. So I'm just going to tidy it all up. So I've got Amari, Jocelyn, Xavier, and whatever. And we've got job 1, job 2, job 3, job 4. And I'm looking at my green numbers and deducting. So 4 has to have 2 minus. So that one became 2. This one became 1. That's still 5. Then I've got this one became 5. This remained 0, 0, and 0. This one remained 0, became 0, became 4, stayed 3. This one stayed 1, became 2, came 1, and actually this one came 2. Sorry, down here. Yeah. This one on job 2, we had to add 2 to that 0. So I'll just change that. That was 2, and this one was 0. So now I can do the cross method now. If I go, all right, 1, maybe 2, you can see the only minimum way is going to be 4 lines, okay? You can't do it any other way. So now I can allocate the zeros will be the jobs for those people. Okay, so we got the zeros, so then you could create your algorithm, or you can just quickly allocate it now. You can draw up the bipartite graph, or let's just look. We can see Amari, she's going to do what? Job 1, and I can see Ying Chu or whatever, he's going to do job 4, and so that's job 1, and then who else? Job 3 will have to go to Jocelyn because Amari's already done a job. And then I've got, what job am I missing? Job 2, and that's going to go to Xavier. Okay, and then what you have to do, you have to go back to the original data and see what that was. So Amari took 4 minutes to do job 1. Ying on job 4 took 5. Jocelyn took 6 for job 3. And Xavier did job 2 for 3 minutes, or whatever it was, and ended up being 18 units, the same. With this one in this example 6, we're not going to do it via Hungarian method because what this one actually says, it says the following shows a score out of 10 each employer would receive for completing a job. Who should get the job? Generally, we say the higher the score, the better the person, yeah? So this one, you want the highest score to go. So just this one would be a case, you just do an inspection. So, but be thinking you want the highest score, yeah? So all you do is do what we were doing for inspection. And we just went through, and instead of circling the lowest, I'm getting the highest for everyone, okay? And then you just allocated the jobs. which looked like it evenly went out there. So Ben did job 1, so he'll do this one. Tom will do job 2. We're going to get Max to do job 3 and Oscar to do job 4. That was pretty easy, but just had to take note that it was the highest. They wouldn't get you to do the Hungarian for that. They'll just do an inspection one you could do.